Hello everyone, you're welcome to my YouTube channel. I am Precious. Okay, so in this video we want to look at the concept of trigonometry as an area of mathematics which deals with the study of triangles. Basically a special type of triangle which we call a right angle triangle. And of course it also extends to other types of triangles, but it begins with this type of triangle which we call a right angle triangle. That is a triangle that contains an angle 90 degrees. Remember that a triangle is a polygon of three sides and three angles. Okay, so now when you have a right angle triangle, we usually will define the sides of the triangle. So if there is an included angle here which we can call theta, so we can give label to the three sides of this triangle, where this side facing the angle 90 degrees is which is also the longest side, is called the hypotenuse, so which we can shorten this way. And then the side facing the given angle is called the opposite, and then the other side is called the adjacent. Okay, remember I said that trigonometry deals with the relationship between the sides of a triangle and the angles of that triangle. Okay, and so it's just the branch of mathematics that deals with the connections, the interactions between the sides of a right angle triangle and its angles. Okay, so the implication is that if I have a right angle triangle this way, let me say something like this, and my angle 90 degrees here. So let's take it that my included angle, maybe alpha, is here. So the opposite of this one is here. The hypotenuse will be here, and this place will be the adjacent. So you will need to get your opposite. Of course, the hypotenuse remains the side that is facing the angle 90 degrees. Okay, now, so how do we get these relationships? All right, so these relationships are now what we call the trigonometric ratios. Okay, so the trigonometric ratios give us the relationship between the angles and the sides of these right angle triangles, and there are basically three of them. And then from these three we now will get up to six, the other three being the reciprocals of the basic three. Okay, so the first is what we call the sine. Okay, so the sine gives us a relationship between each of these trig ratios, give us a relationship between two sides of the triangle. So we have the sine, the cosine, and then the third called the tangent. Okay, so now the sine connects the opposite and the hypotenuse, while the cosine connects the adjacent and the hypotenuse, and then the tangent connects the opposite and the adjacent of the triangle. Okay, so we, in a very quick way, we are going to be seeing what these relationships are. All right, and I want to agree that you would have heard this particular short statement called SOHCAHTOA, right? So, and what is SOHCAHTOA? Now, the so is on its own, and then you have the car and the toa, okay, each being a representation or an abbreviation for the relationship we want to talk about. Okay, so for the first one, the sine of any angle, say theta, is equal to the opposite to that angle all over the hypotenuse of the triangle in which you have the angle. Okay, so if I have this as a right angle triangle, where here is a right angle, that means this is H. Let me call that H, another name, maybe C. And then here is A, and here is B. So the implication of that is that if here is my theta, then the sine of that angle theta is equal to the opposite, which is A, all over the hypotenuse, which is C. However, if I have another angle here, maybe I should call it beta. Okay, so the meaning of that is the sine of my beta is going to be the opposite, and the opposite in the case of beta is B, and that is all over the hypotenuse, which remains C. So the meaning of this is that your opposite and adjacent can alternate depending on the angle you are referring to. So but your hypotenuse remains the same. Okay, so and that's where we got this abbreviation SO. So meaning S for sine, O for opposite, H for hypotenuse. And then for the second one, which is cosine, so the cosine of an angle is equal to your A being the adjacent all over H being the hypotenuse. So that is to say, using this same diagram, the cos of the theta for that diagram is going to be the adjacent, which is B, all over the hypotenuse, which is C. And then for the second one, the cos of beta there is going to be the adjacent. The adjacent of beta will now be A. So that will be A all over C. Okay, and so finally for the last example we have here, for the last ratio, which is called tangent. So you can abbreviate it as tan. Now this is the abbreviation of sine, and this is the abbreviation of cosine. Okay, so the tan of theta of any given angle by this abbreviation is the opposite all over the adjacent. And so if we use the example of that diagram, it means that the tan of theta there is going to be equal to the opposite of theta is A, and the adjacent is B. Okay, and then for the beta there, the tan of that beta will be the opposite is B now, while the adjacent. So it will just alternate. Okay, and that is how to make use of these trigonometric ratios. However, like I said, there are the inverse ratios, which will give us the other three ratios that make up the six ratios that we have. So there's the inverse of sine is called cosecant, so which is abbreviated as cosec. So but there is fully written as cosecant. So this is equal to 1 all over sine. So the implication is that if I have the cosec of theta is going to be equal to hypotenuse of the triangle all over the opposite. Okay, and then and then for the opposite of cosine is called secant, so which you can write as sec. So the sec of theta is simply the inverse of cos, which is 1 all over cos. And if you cos theta, and if you take that, that means you should take the reciprocal of h over a. So the reciprocal of a over h, sorry. If you take the reciprocal of this, that will give you the secant. Okay, and finally for tangent, it is called cotangent. Okay, so that is cotangent, which you can abbreviate as cot. All right, and the cot of theta is 1 all over the tan of theta, where your tan of theta is opposite over adjacent. Therefore cot will be adjacent all over opposite. Okay, and this gives us the 6 trigonometric ratios which we are going to be looking at in under our study of trigonometry. So if I bring the other ones here, my cosec, which you can actually also write this way, cosec of theta is hypotenuse all over opposite. Right. So now these relationships, like I say, allow us have interactions between the between the sides and the triangles of a given right angle triangle. Meaning that with that, we should be able to find some missing sides if we are given some of the sides and the angles. So you can actually be given maybe A and B, and then you are asked to find C, and so on and so forth. Meanwhile, before we go to that, we recall that there's a relationship between the three sides given by the theorem, the popular theorem we call the Pythagoras rule or the Pythagoras theorem. So this rule states that the square of the hypotenuse is equal to the square of the opposite plus the square of the adjacent. Okay, so if I have this, I should be able to find one of the missing sides if I have the other two. Okay, so now let's go into some examples. Look at this. It says find the missing values in the diagrams. So for number one, we are looking for x and y, and we can also actually look for this angle if we want. So in this case, we are given angle 60 here, there is angle 90 here, and so we are asked to find, of course, to find this angle is actually simple. You may or may not use your trigonometric ratios. Either of the ways, you will always get the same answer. All right, so let's quickly look at that. So for the first one, I want to get my x. And so how do you do that? You first of all give labels to the sides of the triangles. So from this included angle, our x is your hypotenuse, and the y is since I'm looking for x, let's take care of that first. So my x is the hypotenuse, and the one we are given is the adjacent, since y is the opposite of this angle. So that means 20 is the adjacent of the triangle. So now, when you know the things you are given, it will help you to know which of the trigonometric ratios that will help you get what you're looking for. Now, which of the trigonometric ratios is related to hypotenuse and adjacent? That is cosine. And so that means if I use the trig ratio cos of theta, which is equal to adjacent all over hypotenuse, and then I can make substitutions, it means that the cos of the angle, which is 60 as given here, is going to be equal to the adjacent, which is 20, all over the hypotenuse, which is x. And they are asking me to find x. So all I need to do now, remember this is over 1, so I can cross multiply this way. And so I will have that cos alone is equal to 20 all over the cos of 60. So remember that if you cross multiply, you get cos 60 to be equal to 20. So you divide both sides by cos 60, and that will give you this. So from here, my x will be 20 all over the cos of 60. You can use your calculator or four-figure table to find the value, and that's going to give us 0.5. And when you divide 20 by 0.5, your x value is equal to 40. All right, so our x is equal to 40, and we can then look for the value of our y. Now for y, your y is the opposite, and so we have opposite and we have our hypotenuse now. But meanwhile, originally we were given the adjacent, and so that means we can make use of tan. So tan connects adjacent and opposite. So we have that tan theta is equal to the opposite all over adjacent. So the meaning is that the tan of 60 as given in that diagram, the opposite of this 60 is y all over the adjacent, which is 20. And so this is also over 1. If I cross multiply, I will have that y is equal to 20 multiplying the tan of 60. And what is the tan of 60 degrees? That is in surd form. That's going to give us root 3. You can actually leave it in surd form as 20 root 3. And that is your solution for your y. And so look at this example 2 here. Here we are asked to find a and b. So they are the missing sides here. So quickly, you can see that your a is the opposite and you're given the adjacent, which is 40. Sorry, the hypotenuse, which is 40. So if I use, that means sine. So it means that sine of 30 given in the diagram is going to be equal to the opposite, which is a, all over the hypotenuse, which is 40. So that means that my a, remember this is over 1, my a is going to be 40 multiplied by the sine of 30. Remember to always put degrees on this your angle because they are angles, and that is equal to 40. The sine of 30 is 0.5 also, and that's going to give us 20 as our solution. And then to get our b, the trig ratio that relates our b and this, your b here is the adjacent and you have your hypotenuse, so that will be cos. So we have that cos 30 is going to be equal to adjacent, which is b, all over hypotenuse, which is 40. Take this to over 1, and so we are going to have that b will be equal to 40 multiplied by the cos of 30. And what is cos 30? Cos 30 is in short form root 3 all over 2. And of course 2 will cancel this to give us 20. So that is going to give us 20 root 3 as our solution. But of course, if you use your calculator, the cos of 30 will be approximately 0.8660. Okay, so but in most cases they will always ask us to leave this in short form. And of course, in our subsequent video, I'm going to show you how cos 30 is equal to the root of 3 over 2. We will see that under the trigonometric ratios of spatial angles. All right, so the final example we have here, in this case, they're asking us to find the missing angles. Okay, so to get, you can choose any one you want to find first, maybe the theta here. So if I want to look for theta, the side facing theta is not given, that's this place. So we don't know this angle that I just represent, sorry, this side that I just represented as x. So but you're given 3 and 5, and with respect to theta, this 3 here is the adjacent, your 5 is the longest side facing the angle 90, which is the hypotenuse. So I can make use of cos in that case. That means the cos of that theta there is going to be the adjacent, which is 3 all over the hypotenuse, which is 5. And so that's going to give me that cos theta is equal to 3 all over 5 is 0.6. Now, when you want to get the angle that is contained by as an argument of a trig function, all you need to do is to take the trig function to the other side. So if I take cosine and it crosses equality, it changes to the inverse. So this will be the inverse of cos, and that will be of 0.6. Look up the value of this using your calculator or your 4-figure table. So if you're using your calculator, you just press the inverse of cos and then put your 0.6, and it will give you approximately 53.1 degrees. Remember, it is angles and it's measured in degrees. All right, and that's to 1 decimal place. You can choose to take it to 2 decimal places as the case may be. And so for the second one, you can see that the angle alpha there, using the given sides, the 3 here is the opposite, your 5 remains the hypotenuse. So you can choose the appropriate trig function that will connect this angle and the 2 sides given, and then use it to find the value of alpha. And let me see your solution in the comment section below. All right, This is where we'll end it for this video. Kindly subscribe to our YouTube channel and do give a thumbs up to this video, and we will see you in our next video. Bye.